Hello and welcome back to Nature in Code. So we're still in the process of implementing Hardy-Weinberg in JavaScript, and this is the current status of our code. Things work well. Um, in the last lecture, we implemented this function here, which is a nice way of making sure we don't repeat ourselves too often. That's the whole idea behind a function, that you can encapsulate some code within a function and then just call that function whenever you need that code to be executed. However, you may have noticed that I still did some copying. In this case, I just copied the function name, which isn't as bad as actually copying, calculations all over the place, because it's pretty unlikely that the function name is going to change. But in any case, this still doesn't quite feel right. And why not? Well, I mean, if you look at the code, we had the task to make sure that we calculate genotype frequencies over 5 generations. And so, I just went ahead and I copied the function call here and then the console log statement. But imagine I asked you to do that for 100 generations or 1,000 generations. Then what? Would you go ahead and copy this code 1,000 times? Probably not, and it wouldn't be a good idea. So this is where the concept of iteration comes in. And to me, that is absolutely fundamental, probably the most fundamental principle about all of programming. I mean, ultimately, we use programming to make our lives easier and to basically have a computer do things at a speed that we just can't do. And by and large, that is by executing certain functions or certain expressions again and again and again and again, thousands, hundreds of thousands, millions, or even billions of times. And so it would obviously be pretty strange if we wanted to execute a code 1,000,000 times and we would have to write a million statements for that. That is where iteration comes in. So basic iteration allows you to say, hey, computer, do this, whatever this is, n number of times, and n can be a very large number. So in our case here, in this small example, we could say we would like an iteration that says, hey computer, call this function here, create next generation, 5 times, and also call this line here, console log, where you output the genotype frequencies 5 times. So how would we do this? Well, it turns out there are a couple of different ways to do this. The one that we'll use most frequently is the for loop. And I just want to show you real quick what the for loop is and how it's structured. So basically the for loop in JavaScript is structured as this. So you say for, and then in parentheses you have 3 things. Okay, the first thing is an initialization. Okay, you initialize a variable, and I'll talk about this in a second. And then after the initialization, there should be a condition. Okay, condition. Again, another semicolon, and then there will be a final expression. Okay. And now let's close these parentheses. And now just like in a function, we now have these curly brackets. And within those curly brackets, we can have basically the code that is to be iterated. And so here's how this works. So first, the initialization code is executed once right at the beginning. And then as long as this condition is met, this code will be iterated. So as long as this condition is met, the code here will be iterated. After each iteration, this thing here, this final expression, is executed. Okay, so that's how it works. Okay, so this is the initialization. Then as long as the condition is met, this code here is iterated, and after each iteration, this final expression is executed. So how does this work in reality? Well, I can show you an example, and I'm actually going to do this in the JavaScript console here. So we could have a code that says for, and now here in parentheses, I would say the following. So the initialization is going to simply initialize a variable that I'm going to call I, and I'm going to set it to 0. Okay, semicolon. So that's the initialization. Then I'm going to say I is smaller than 10. That is the condition. And finally, I'm going to say I equals I plus 1. So that is the final expression. And then in parentheses, I could define a function body here that could be as simple as printing the value of I into the console. By the way, if you do this in your console, just be sure that as you hit return here, that you hit shift return, okay? Because when you hit return, it will just execute the code, and that you might not be finished writing your code. So just hit shift return, and you can add as many lines as you want to. All right, we're gonna run that in a second, but I just want us to walk through this code real quick. So this is the initialization here. We initialize a variable called I, which is pretty standard practice in a for loop, and we initialize it at value 0. Okay, so that's the initialization. Now, as long as this condition is true, which says I should be smaller than 10, this code will be executed. However, after each execution of this code, this expression will execute it as well. And the way to read this is you take whatever is in I, you add 1, and then you store it back into I. So this I equals I plus 1 basically increases I by 1. Okay. So let's run this. Okay, let me just hit enter here. And you see that this code here was actually executed 10 times. Okay, it started at 0. It printed I equals 0, then I was incremented by 1, so in the next iteration it printed I being 1. It was iterated, incremented by 1, excuse me, so then it was 2, and so on, 3, 4. And then finally, after this line was executed with the value 9, I was incremented again by 1, which now means that I is 10. So the next time we go into the loop and we check this condition, well, now this condition is not true anymore because 10 is not smaller than 10. And so that's when the loop stops. And ignore this undefined here. Basically, whenever you print something in the console, most of the time it just says undefined at the end. That's nothing to worry about at the moment. But so I hope you understand how this code works. This is really, really crucial. And of course, we could have said here I is smaller than 10,000, and this code would actually have executed 10,000 times. But so you can see why all of these things are important. Obviously, you need some initialization in the beginning, otherwise, there's no variable e to work with. You need some condition. Otherwise, if you don't have a condition, well, you have an infinite loop. This loop will just run and run and run, and it will never stop. So that's what you have this condition for. The condition itself, however, of course, is not good enough. You need to make sure you have this increment over here in this case that actually increments I by 1 in each iteration, so that there comes a point where that condition is not true anymore. Otherwise, you would be in an infinite loop. You'll probably just as you learn programming, that's just a common mistake you'll make, and this is actually probably the easiest mistake to spot because your code will just never finish. And if your code just doesn't finish and your computer starts, either getting warmer or your fan, the computer and the fan in your machine start making a lot of noise, that's because you somewhere programmed an infinite loop that's just executed billions of times because somehow here you made a mistake either by setting the wrong condition or by forgetting to increment a value or something like that. So, but that's thankfully quite an easy mistake to spot. But that is the structure of a for loop. So let's go over to our Hardy-Weinberg code and now implement this idea in our code here. So what we would like to do is we would like a for loop here. Let's create this here. For and we would like this to run 5 times. So the initialization here is also going to be var I equals 0. Then I'm going to say, okay, I needs to be smaller than 5 as the condition. And then I'm going to increment I by 1. And now the code that needs to be iterated is first the call of the function, and then second, this call to console log. All right, let's make sure that this is nicely aligned. Okay, now I can get rid of this. So now this code here will be executed exactly 5 times. And so let's just save this, go back to the browser, reload the document, and you can see here, this is actually indeed happening. So this is actually Chrome, the JavaScript console of Chrome being nice here. It's printing the exact same thing 5 times, and rather than doing that 5 times, it realizes, hey, this is the exact same line that I'm going to print 5 times. So I'm just going to print it once, and I'm going to add a 5 here so that you know this is actually being printed 5 times. However, we need to fix something here. We don't want this to say generation 1 5 times. We want it to say generation 1 and then generation 2, generation 3, and so on. So let's go back to the code and fix this. So here is the problem. We're saying generation 1, but in fact, we would like to say generation 1, 2, 3, 4, and 5. So keep in mind, we have this counter variable here, I, that starts at 0 and ends at 4. So what we want is basically, we want just, we would just like to print that variable, except we would like it to be 1 larger. So I'm going to say here I plus 1. And then using string concatenation, I'm just going to add those strings together. So this will now say generation, whatever the value is in I plus 1, okay? Then the colon, and then these values here. So let me save this. Let me reload this over here. And now you can see, whoops, made a mistake. Oopsie, okay. Of course, the plus here shouldn't be here. All right. Fix the mistake. And by the way, I'm going to do this throughout the videos. I'm always puzzled when I watch videos where people teach me how to program and they never ever make mistakes. That's really nice because it's been cut and edited. But I want you to see the reality that, even I, who has basically written the book on this, I make mistakes when I type, and it's good to see what happens when somebody makes mistakes and you go back into the code and you sort of try to figure out where exactly the mistake was. But in any case, you can see here that the code works now perfectly fine. We have generation 1 to 5. And just as a sanity check, we could now go back and say, hey, you know what, do this for 50 generations. So I'm just going to make this condition here to be 50, save it, go back, reload it, and yes, here it is. Okay, 50 generations and so on. You could of course do this for 500 or 5 million generations, but I'm not going to do it. I think you get the idea. So this is now the pretty much the final product of our code, and it's pretty nice, isn't it? Look at how much more compact this is now. We have no more duplication. Our functionality here, where we calculate the genotype frequencies based on the allele frequencies, they are nicely encapsulated in a function, and then using a for loop, we iterate 5 times by calling this and call this function here 5 times, and this console log statement 5 times, or however many times we want to. So I hope you have this working in your computer, and if you have, then congratulations. So A, you implemented Hardy-Weinberg, which is already pretty neat, but B, you really implemented a nice JavaScript program here that uses a function, that uses variables, some math, and that uses iteration. And I know it sounds a little bit strange, but you've now essentially covered 90% of what there is to be known about JavaScript and about programming in general. I mean, I may be exaggerating a little bit, but it is actually quite close to the truth. If you look at code, it's largely about manipulating numbers and strings, data essentially, using iteration and using functions. And if you understand everything here, which I hope you do, then you're really on a perfect track to learning JavaScript. And there's a few more cleanups I would like to do in this next lecture. But congratulations, and I'll see you in the next lecture.